Alright, when December the 9th. Alright, let's do it. Find longest special substring that occurs three times, right? You're given S lowercase English letters. A string is called special if it is made up of only a single character. For example, string ABC is not special, whereas a string DDD, ZZ, and F are special. Return the length of the longest special substring S, which occurs at least thrice, or -1, no such special string occurs. No special string occurs at least thrice. A substring is non-empty. Okay, we know what a substring is. So we want a total number of substrings. The first one is 2 because AAA and AAA, right? So say at least thrice. Wait, hold on a second. A string is special if it is made of only a single character. Return the length of the longest special substring. Which occurs at least thrice. Oh, hold a second. I think I read it wrong. Oh, it's not the substring contains 3 repeated letters. It's the substring itself that occurs 3 times, or at least 3 times. Oh, that's very different. If it is a special, if made of so we need to first find the substring that is special, which is repeated, and then return the length of the longest special substring, longest this repeated string that occurs at least 3 times. Yeah, so the third example is A, right? A occurs 3 times. Oh, I think binary search can do this. Alright? Can binary search do this? So longest substring, we set a value and then we just search through. We search through one like sliding window. Like we say, because S length is 50, so I say 50. No, just like half of it. Alright, and we just go through the whole thing, we create a counter. Right? And then, because this substring we need to occur, so we create a counter, we have, is it good? Right, so it's not good, so we go next one. So when it's good, then we can say, okay, so we have the base, right? The base occurs how many times? And then move to the next one. We'll get it, and then we say, okay, this one occurs twice, and then occurs 3 times. Then we, oh, no, this is just, you just go the longest, and then you start going down. Yeah, maybe we can go through and then find the longest. No, we can. Like we do the longest, it's no good, so we do this. If it's good, and we go, okay, yeah, we probably can binary search this. So now the question is, if we binary search this, we need to know, how do we do map or counter in C++? How do we do counter? Oh, just do map. Oh, okay, do unordered map. Okay, unordered map, can we unordered map? So we're gonna have 2 unordered map. Erase element. So we need 2 maps, right? One map is to keep track of the current frequency of all the numbers, all the letters. And another one to keep track the other one doesn't have to be keep tracking. I think the other one we can just we just keep track of the number of times that a special string has occurred, right? And then once we go through, we can go through the other one and then see which one has the largest value. Yeah, and if we do binary search, right, we have, if something is not good, we just go down. Okay. All right, let's give this a shot. Give this a shot. Okay, so first thing we need to do is unordered map. I'll say it's a char. And this is int. Counter. Frequency. Sub str frequency. Okay. Oh, I could have done. This is substream frequency. This is no, we call it letter frequency. This is str count. Okay. Do we have like contains or any insert in place? Count contains. Okay, we have contains. All right, so what we have now, we have in low. Ooh, what is low? Because it could be -1. So we set low to 0. Okay. High we can set to s dot length. I think usually it's -2 because you need to have at least 3, right? Okay, then we say while low smaller than high, mid low plus high minus low divided by 2. Okay. Now what? Now we're gonna go through letter frequency dot clear. Okay. And str frequency, str count dot clear, right? We clear both. And we're gonna go through the whole thing. For say I equals 0, I want s dot length, I plus plus. Ooh, s dot length. Okay, let's say equal to s dot length. This is n. This is going to be n. Okay, then we will first add it. Okay, we say if letter frequency dot contains si, if it does not contain, right? Oh, can we set everything to 0? I don't know. The default value. I think the answer is default has used this here key. I don't want to read this. I think, wow, it does say when you access, oh, it's overloading this operator. Holy crap. When you access element using this operator with a key that does not exist, a new element is inserted with the default value of the value type. Oh, so in this case, accessing non-existing key creates an entry with default value 0 for, so this has become 0. Okay, now let me read this one more time. What is this? This is a map, a foo, and my map apple doesn't exist, right? So we create a foo and num. Both are 0. Use at instead. New items added to both this and this via the array index are value initialized. The result in the key being copy constructed from key and the mapped value being value initialized. When the default is used, the results in the key being copy move constructed from key and the mapped value being value initialized. You do not provide a constructor, which means that each field in full will be value initialized individually, which for primitive times means 0 initialization. But the problem you're actually facing here is that the field called maple does not exist in your map. Unfortunately, the semantic are such that if the value does not exist, it will create it on the fly. Probably didn't even want to access non-existent value in the map, and you are asking whether it is always initialized to 0 so that you can use this fact to check whether the element was there. For this purpose, however, you should either use the find or add member. Find will return an iterator pointing to the end of the map. If the element does not exist, it means you could guard the element using this. What the hell is this? You can auto this and then check it. At will throw an exception if the element is not find. Okay. But in my case, it's a counter, so I'll just use this. Okay. Which means I don't have to do the contains, right? So I'll first do letter frequency. We can just do this, right? Plus plus. And then we'll say if, right, I plus 1, right, if I plus 1, which is the number of letters in it, if it's larger than mid, right, then we need to remove the 1 in the front. And then how do we remove? The one we need to remove is going to be, let me think, 0, 1, 2, 3. Okay, so if I have 3, then it's to be this I minus. So I minus mid is the index. So basically, we need to say this frequency si minus mid. This is gonna be minus minus, right? Oh shoot, minus minus. and we say if frequency si minus mid, if it's equal to 0, right, then we need to say dot erase. Okay, we'll erase it, right? If it's, that means if it's too big, then we should erase it. Okay, and once we're done, right, once we're done, then we'll say if I plus 1 is equal to mid. Okay, so we have the length, and letter frequency dot size is equal to 1, right? So this is when we have a special substring, right? Special string. So now we need to know what is in. So how do I get another map? Get key, get one key. How do I do that? Oh, I can do begin. Yeah, I use iterators. My map.begin and first. Okay. I think begin is good enough for me. Because it created iterator, now we just called the first. Oh, I already remember. I don't remember. Well, this is a value, right? Actually, I don't know. I forgot. Is this pointer or? Oh well. So we'll say dot begin. Okay. Then we can say char letter should be letter frequency dot begin, right, dot first. Oh wow, good, automatic. Okay, so that's the letter, and we say string count letter plus plus. Okay, so we go through this, right? Remove this, if this, go, and then we go on next one, sliding window all the way down. So once this are all done, right, all done, then, because we're saying if mid, if this length, we can create at least thrice, right? So we just gonna go through the str count. So how do I iterate through another map? Iterate an ordered map. Auto, const auto pair. Okay, const auto pair. So we say for const auto pair str count, right? If no, what we want is int count, right? We just say count equal to std max pair dot second and count. So we get the maximum count, maximum string count. Now we say if this count, this is repeated times, is larger or equal to 3, right? That means it's possible for us to get it even higher. Else we say high equals mid, right? If it's not, that means it's no good. So we have to keep going down, right? So if it fits, go up, and at the end, when we get out, it's because low we try up, so it should be low minus 1, right? So it should be low minus 1. So in here we can return low minus 1. All right, let's give this a shot. Just run the first one. That is pretty bad. What the hell? 1, 2, 3, 4. 4 minus 2. Okay, I think it should be minus 1. Because minus 2 is the largest, so you should not reach it, right? You should not reach it. Nope, still no good. So it'd be 3. Alright, 0 and 3. It should be 1, right? Mid is 1, okay. Mid is 1 and I is 0. So, okay, that's good. And I minus 1 is larger than mid? No, it's not. So it's equal to mid, and its frequency is equal to 1, right? Then letter, I get its letter, and this, yeah, take a letter plus plus, okay? Now I go to the second one. So it become 2. Letter frequency, right? And I plus 1 is larger than, so I will remove the previous one. Okay, let's debug. I couldn't figure out immediately what went wrong. It's like every single time, every single day, I'm having this issue of having to debug. Getting really, really, I think we can initialize it like this, right? Getting really bad, because like every day I have to do this, and I don't like it. Although it is fun. I mean, debugging is always fun. I always like debugging. Alright, so I have this. Okay. So mid is 1. Clean. Okay, so this frequency gets up. 8. That's good. And yes. Okay, letter is A, str count. Okay, str count also, A is 1. Back up. So now I is 1. Right, where is I? Yeah, I is 1. So I is 1, then A become 2. That's good. This is larger than, so I need to remove. Okay, equal to 0, no. Coming here, yes. Ooh! I see, I plus 1. That's not true. Oh, I see the problem. I think the problem is this is need to be larger or equal to. Alright, this should be larger or equal to. Let me run this again. We can actually do this. 2024 12 challenge main. Yep. Right, that's the answer. So this should be a larger equal to. All right, I may be right. What do I call it? I call it 29A1. Binary search. Binary search. For each potential special substring length, we use sliding window to find the max number of repeats of a potential special substring. Okay, so ON because ON log n, I think, because this goes log n time. Inside this take ON time, and this has to go. This is a constant time, so yeah. Okay, let's check. Hopefully it will pass everything, and then we can just call it a day because it's already half an hour. It does pass. Thank goodness. Okay. Brute force optimized hashing. Huh? How do you count ON squared? We are not, right? We are doing sliding window. So we go through this. Yeah. Let's just read. Okay, so basically you use this substring length count character. Oh, count character substring. Ah, I see what it's trying to do. So from any character with the substring length, because you go through every single time, and then we just go through this, and then go through count. The first, the second is the substring length. If I dot second is larger equal to 3 and length is larger than answer, Yeah, because we want the largest length. Yeah, this is the largest length. Because the length is larger than the answer, then we swap the answer. Right, and then at the end, if it's, I think, I don't know. I think this is better than this, right? Oh, the second part of this problem. You know what? This is exactly the same solution submitted for 2981. Right, since it is binary search, it may pass this version as well. We'll see. We'll see. The constraint is much worse because it's 5 times 10 to the 5th. Let's try it. Maybe it pass, maybe it doesn't. Yep, it passed, but with very bad runtime, right? Very bad runtime. So we do need to find a, what should I call it? A ON solution for this. ON solution for this. Something to think about, right? Something to think about. Okay, that'll be it. I'll leave this one open and we'll think about this. I'll see you guys tomorrow. Adios.